Good afternoon, ladies and gentlemen, or I should say everyone. That's the new phrase these days, everyone, not ladies and gentlemen. Nice to be with you. Beautiful conference, beautiful country, beautiful hotel conference. Thank you very much for inviting me. I'd like to start by saying if you came here to learn about secrets on U.S. Navy submarines, you're in the wrong conference. What I would like to tell you is, according to what I heard this morning, AI started in 1956. We at General Dynamics started it in 1969. We lost two of our nuclear submarines in rapid fashion, one in 1963, the Thresher, and one in 1968, the Scorpion. We lost them because we had no backup to stop a rapid dive. And the rapid dive is something that it's like a crash to airplanes, but in submarine technology, the submarine actually crushes as it gets to depth. And that's what we had to overcome to try to figure out how we would stop on these nuclear submarines for them to actually not continue a dive if a system failed. So what we did through Mr. Admiral Rickover, who was the father of nuclear submarines in the U.S. Navy, he called us all together, airplane manufacturers, as well as shipbuilding and submarine people, and said, look, we have to find a way that if the system fails, something kicks in automatically. And that system is what became known as the Level 1 Sub-Safe program for the U.S. Navy. And what it did, it provided two parallel systems that if one failed, the other one would kick in automatically. Since 1968, knock on wood, we've not lost another submarine. All the rest of the countries, Russia, they've lost 10s and 12, 13 submarines because they didn't have the same system that we had. So I really can't talk about how that works, but in my new life of getting into the power industry, we feel, as I felt then, that on power stations, we need to have the capability of efficiency, failure, the ability to move in the direction that we need to move in case of weather, sabotage, whatever system that would be employed against the power plant. We want to make sure that we've got the capability to deal with it efficiently and make money. So, that's one of the submarines that I worked on, helped build, and I have to tell you that looking at it now, it's fond memories, but I've been on many of them, making sure that the backup systems are working, because my job was in that field of the equipment needed for the backup. We were making it, and it works very well. What we're trying to do now, with the help of some really good people, is to build the world's first cognitive AI power plant that will employ the features of AI in the operation of the plant. This is not easy. It's capital intensive. Any of this work that we're going into has tremendous capital requirements, but it also has to have people that have been in the industry for some time And we're happy to have those kind of people like Ray Handley, who's here with me today. General Electric is one of the companies that we're working with and hope to have success with them in building this AI cognitive power plant. When you get into the lack of power, and we talked about it today, there were, I don't know, 85 billion people with no power or something. We're working with a small country in West Africa, and it is totally lacking electricity. It's beyond, they have half of what they need right now, and probably with the heavy mining industry coming in, they're probably less than a quarter, 1/4 of what they need. The big idea here also is that we have to supply the electricity so that it's in abundance, non-failing, and the ability to get it to the people cheaply. We are not, at this point in time, working in the solar industry. We're working in the area of liquid natural gas, being the supplier of the fuel for the power plant. And to this, as you know, LNG is becoming a very favorite fuel for a lot of things around the world because it can be transported easily. I might say that my company, General Dynamics, at that time, we built the first LNG carriers. And we were kind of before the state of the art, so it didn't go very far, but we did build 5 super tankers that were LNG carriers. So we have lots of challenges. Efficiency, we talked about, plant shutdown, risk identification. You know, in what we try to think about in terms of efficiency, weather, the type of fuel, the quality of the fuel that we're ingesting, and at all times, the ability of the machines to work at full capacity. Identifying the risk can be weather, workforce. Did you train the people properly? Did you get what you need at the beginning to have good employees that can understand the equipment, training, the ability to identify risk when they happen? Site-wide communication is huge in that you want to have the most current data coming back to you. And if your site is not communicable, you got a problem. So we're going to go into the things that empower nations, business, and communities. And for that, we're looking at this small West African country to be able to pick up all of this with just one 850 megawatt power plant that we're designed to put in for them. The human ability in AI in the power plant, we are acknowledging that we want to hire the local people of the country to work in this area. So we want to be sure that our training programs are the highest level. And as everything we heard about this morning, those are the things, the universities that we need to work with, the actual from offshore, call it, people coming in to help out at the beginning. This is all what we need to get to on the knowledge base, the power plant data, explainable audit trail, and at the end, operator capacity to operate properly. Our vision, and don't ask me why, there should be somebody other than a small West African country getting the first cognitive AI plant, but we think it's okay. We think that that's probably a way that we can focus and concentrate more by having it in a place that is not so popular. So we want to focus on all the things that we've just talked about in the cognitive power plant area. We want to make sure that when we start the operation, it's a go forward proposition, not go backward. We want to make sure that everything is in place as we begin. This industrial growth that we're talking about in this small country, they have about a quarter of the energy they need right now, but with mining companies coming in that are going to pick up the large natural wealth of the country, we want that not to be an exportable product. We want it to be a processing product for the country so that the country benefits from the final product or semi-final product in aluminum, steel, and some of the bauxite that we're working with. So that's a big thing for the country. It'll actually accelerate the growth of the country, very much. And we're looking forward to that. We're looking forward also in some of the mining operations to be capable to help them as well in the AI side. Exploration in these small countries will expand tremendously because of some of the AI capability that we have. We have a unknown capability to scan the earth and know what's there in terms of mineral and petroleum. And that's another part of the side that we're going to be working on. All of it relative to data. Have to have data to go forward. Thank you very much, and I guess we can take a question or two if we have time. Thank you very much. We have a question in the back.
Why did you choose to incorporate AI in a power plant instead of others, like fields that can be more successful?
Good question. I was introduced to AJ by some people that got me into Beyond Limits, and they were the convincing factor to go into since we're already moving into the power industry and the mining industry, it was easy for me to make that choice. Okay, thank you very much. Nice being with you.